All right, so this is going to be another video about solving separable differential equations. So we have this differential equation right here, dy over dx is equal to x cosine x squared all divided by 4y. The first step for separable differential equations is to separate the x's and the y's on each side. So I'm going to do that real quick. All right, so you end up with something like this, what I have in the blue. Now from here, we're going to try to solve for y. The whole point of these solving differential equations is to have an equation where it's y equals something. So what we're going to do to get that y is do the antiderivative of both sides. So we're going to integrate both sides. And what you would get on the left here, the antiderivative of 4y would be 2y squared. So you'd get 2y squared there. And on the right side, if you notice, we have a function inside of a function times this x here. So a light bulb should be going off in your head that we are going to need to use u substitution. So what I'm basically going to do is break this thing out right here. I'm going to break this out over here and use u sub just so it doesn't get confused with what we have right here for the equation. Okay, for the little review here of integration by substitution, generally speaking, the u that you're going to want to use is the most buried function. It's also good to see the pattern that the derivative of that buried function, this x squared, is going to be 2x, which is related to this x right here if we divide by 2. So I'm going to put my u as that x squared. So I'm going to say u is equal to x squared. From here, we need to substitute for this dx here, and the only way to get the dx from this u is to do the derivative with respect to x, and then that dx shows up on the bottom there. This is equal to 2x, and we want to solve for dx. But also, if we end up solving for dx, we end up also finding this x as well, because the x shows up right here. So what I'm going to do is solve basically for x dx in this case. So I'm going to multiply both sides by dx, and you're going to get 2x dx. Now we want to substitute for that x dx, so I'm going to divide by both sides by 2 here. Okay, and then the 2 is going to cancel here, and x dx is equal to du over 2. So I'm basically going to rewrite this integral that I have, that I circled in orange right there, and solve for it. So now I have the integral of x dx is going to be du over 2, so I'm going to put du over 2 over here, and then of cosine u. This should be a pretty basic anti-differentiation problem. The antiderivative of cosine u is sine u divided by 2, so I'm going to put the 1/2 in front, plus c, and the last step would be to substitute your u back in, so your final integral should be 1/2 sine x squared plus c. Now from here, I am going to substitute it back up here so we can solve the problem. So I'm going to do that real quick. Okay, again, the main point of these problems is to solve for y, so that's what I'm going to do next. I'm going to divide both sides by 2 here. These 2's are going to cancel. And then from there, we are going to do the square root of both sides. Now, you don't have to worry about doing the plus or minus on this square root, because if you recall from the very beginning of the problem, up here I'm circling it in yellow, y has to be greater than 0, so you can't actually have a negative square root here. You're just going to keep it as a positive square root. Square root and squared are going to cancel, so you're going to end up with y is equal to, and not worrying about the plus or minus. Now there are instances where you could actually simplify this a little bit more, because this 1/2 divided by 2 would be 1/4, and the constant divided by 2 is still a constant. So if you wanted, you could technically simplify this a little bit more, but for purposes of this video, I'm just going to kind of leave it like this. So your answer is not wrong if you leave it like this. I'm just showing you there is possibilities for you to simplify. So that's basically a problem on how to solve separable differential equations. If you have any questions about anything in this video, let me know.